we make that available on our YouTube channel, and I'm sure Carlos would love to share that YouTube link with everyone. Awesome, thank you. So I would like to welcome Stephanie Gardner with us today. Stephanie is associate professor, but I would like us all to give Steph a huge congratulations that she will be full professor effective August 18. Congratulations, Steph. We're so happy for you. Steph is also the University Undergraduate Research and Mentoring Fellow at Purdue University. Steph is a physiology educator and discipline-based education researcher. She has a doctorate in physiology from University of Wisconsin at Madison, and she did a postdoctoral fellowship in neuroscience at Johns Hopkins University. She leads graduate student and faculty professional development programs around inclusive and innovative instruction, including supporting instructors to increase access to undergraduate research through course undergraduate research experiences. In her fellow role at Purdue, she is working with people and programs across campus to coordinate efforts supporting pathways to and participation in undergraduate research and developing undergraduate research mentors. She's a Pulse Fellow, and I wore my shirt today for Steph. She's a monitoring editor at CBE Life Sciences and serves on the editorial review board of Advances in Physiology Education and Frontiers in Education, STEM Education. And welcome, Steph. We're thrilled that you could be with us today, and feel free to start whenever you wish.
It's so great to be here, and I have to say I've been sad that my schedule hasn't allowed it. I came more often, I mean, during the pandemic, coming to the afternoon sessions was just so helpful to have community during that time. And I always had it on my calendar to come, and it just never didn't always work out in my schedule. So I was so excited when Melanie reached out to me, and to be able to come here and make the time to be with you all. And so this is the title here. I'm going to talk about some of the research that we've done, but then also have an introduction, tell you a little bit about our research project, and then have some kind of interactive sections along the way. And I'm just going to give you a small taste of some of the things we found. Happy to chat more. Melanie knows some about this, and then my former postdoc working with me, Lauren Straczynski, is also here today. And so, there's lots of connections to follow your interest to hear more about some of our data. But I want to give us a chance to kind of talk about practical implications for our teaching and assessment. So I wanted to start off first, and Melanie is going to put this QR code that's into the chat, or if you have you can take a picture on your screen. I have a Padlet, and it has the question in there is, what is something that your students do well, and where do they struggle when creating graphs? And also, please let me know if that link is if you can't get in there. I'm not an experienced Padlet user. Good, Carlos, thank you for the thumbs up there. So I'll just give you, a minute or so to kind of think about that and add in your ideas.
And maybe I'll just mention, if you have not used a Padlet before.
Oh yeah, sorry. Thank you.
Yeah, that's okay. That's okay. When you open up
let me do that.
Yeah, okay.
Let me do that.
There's a plus button. No problem.
Yes, thank you. Yes, I will share my screen. I was going to do that, and then I forgot. So let me just do that. I will So yes, thank you, Melanie. If you're not, have you not used it before? You're seeing the Padlet right now on my screen. Well, you can hit this little plus button down here. So kind of looking in there, which kind of graph is suitable. Reading variability, variables like a which axis they should go on, what the big picture is, formatting, labeling, and titles. You're seeing the Padlet as I'm sharing my screen, correct? Okay, just want to make sure that grouping data. Yeah, and so I'd be curious of grouping. To me, when I see that, I'm thinking of like to facilitate comparisons, or it could be maybe you were talking about whether or not they should like aggregate it and represent it in a mean or a median or something like that, but maybe it was grouping like side by side to like facilitate comparisons. What kind of graphs again? Let's see, other things, transforming it, right? Yep. Yeah. Color, excessive lines, yes. Seemingly, yeah. Oh God, I love to hate Excel and hate to love Excel, right? Yes. What kind of graph is suitable for their analysis? Yeah, so a lot of they are artistic, but they struggle in transforming data. Yeah, so I'm seeing some kind of commonalities here, and they resonate with me in my own teaching as well, and also what we've seen in our research. So thank you for sharing. You can continue if you want to, putting things in the Padlet if you would like. But let me just kind of go back to here. So thanks for sharing. And right, you can see across this group that we share some things in common. And I appreciate that there's some people were saying what they were good at, and then some areas where they had some challenges. And so what I wanted to do is just kind of frame things and then set up some of our research. So you know, you may or may not know of this guide, the BioSkills Guide. It stemmed from Vision and Change, but was more granular and looking at the skills, right? And so this came out in 2020. And let me make sure let me put my pointer on, right? In 2020. And so they broke the skills down more granularly. And where does graphing fall in here? So they had a section on quantitative reasoning. So you can see creating and interpreting informative graphs and other data visualizations. And then also within what they called the process of science. So experimentation and inquiry. And that was in the data interpretation and evaluation. So things related to graphing falls in here too. So it's really a natural part of what we do in teaching science. This is in the context of biology. There may be some folks here who are not in biology or the life sciences, but you know, really this was articulated there and is relevant to me too. And then I always like to go back to, you know, Tufte. So this, you know, his book that was like the quantitative or the visual analysis or visual display of quantitative information. And so what he kind of articulated, was an economist, right? But what he said about graphs really holds true regardless. And graphs are not unique in science or STEM and biology, but really the graphical displays should be showing and revealing the data. Some of what was in the Padlet relates to that, focusing the viewer's attention on display, avoiding distorting the data, present large numerical data sets in a small space. So for example, these are some data here that could be represented in a couple different ways. And again, that resonated with what some folks said. And picking an appropriate graph to represent their data in. It should make large data sets coherent encourage visual comparisons if I was, interpreting the person's intention, right, of like grouping things to allow for comparisons, revealing large and fine trends, and serve a clear purpose, and be integrated with statistical and verbal descriptions of the data. And so really, here's a sample graph here. It's something that we all do. Like, it's a part of the lexicon of us communicating with ourselves and with others, but it's really complicated. So we've reviewed some of the literature and kind of grouped things into these different, areas. Like, what do you need to know about? And knowing about different graph types, certainly integrating that knowing, so knowing about mathematics and statistics, understanding if you're in chemistry and doing an investigation there's things about chemistry, the variables under study, the measurement systems that might be similar or different from what you might do in biology. And then that, the visual spatial, like facilitating the comparisons, create aesthetics, creating something that is visually pleasing, but is also functional and useful. So there's a lot of things that go into this. So when our research group back, before 2012 started really systematically investigating this, prior work really didn't always, there's a lot of literature on how do people interpret graphs. But not as much on graph construction. And even in again, I'm a biologist, so AP biology, it literally told students, make a line graph and then do something with it. So they really weren't actually challenging students to engage in a decision-making process. And previous work, and this is older, right, that students can plot points and identify the coordinates. But then there are a number of things where students had challenges, and that's been documented before. By mechanics is like the physical, like plotting the points, putting things on there, and and doing some labeling, but then difficulties there. And even with like interventions, by that I mean like designing a lesson to teach about graphing and to improve their learning, difficulties can persist. And so, we know that and we know this just generally from how people learn, but then in the context of graphing, and that's what these citations are, that, it needs to be repeated practice and giving students feedback. So this is kind of where we kind of entered the scene. But I always tell my students, and it's in my class. I teach a physiology class in the lab, and we have a whole bunch of stuff we do with graphing. I tell them this, I said, it's not that, it's not just a student thing. I show them this very slide, that there is guidance to practicing researchers. Please do better with your visual representations. And so I just scroll through these first pages of all, I said, it's not a student thing. Even professors have a hard time, right? Just so that they understand that this is a challenging thing. It's a complicated thing, and professors don't even always do it well. And so like I said, I always show this to the students. And so, the work I've had a large group of folks, and I know I mentioned Lauren, she's here today, but a large number of graduate students and postdocs who've been involved for many, many years in this work that kind of leads to what I was going to share, and including what I'm going to share with you today, just a little tiny taste. And so I'm going to tell you a little bit about a project that has come to be through funding from the National Science Foundation, and that is a collaboration with symbiotic software to create some assessments that we called Graph Smarts. And so these pages here, these pictures here are kind of the first page, the landing page, and these digital assessments that represent 6 different biological scenarios. We collaborated with some instructors to come up with compelling stories that would be relevant, especially in introductory biology courses, but biology courses in particular. So that was an exciting collaboration to build out some of those. And then, we worked to develop some other ones as well. So we've created a digital performance-based assessment. Performance-based means that they are actually doing the task, and that it's not like a multiple choice question, like they are actually graphing and engaging in the task. So that's what the performance-based means. And so this project, like I mentioned, it's a collaborative project with folks who I've worked with here at Purdue, a collaborator at California State University in Fullerton, Symbiotic Software, and then more recently with some collaborators at the University of Pennsylvania. With our overarching goals, we wanted to develop an assessment to generate an evidence base from which we could then make recommendations for instruction, right? So we felt like we needed to know more about what students knew and knew how to do, instead of jumping right in, let's just design a bunch of things, right? So we wanted to generate the evidence base. And so that's kind of our goals there. And so what we have, I showed you those, like kind of that front matter, those pictures, is we have an example. This is an example of the biological scenario and how we have constructed this. And so we give students a very, very brief background just so they can understand the basic context, not a lot of detail. We have a fictitious research group. And so we tell them about the research question that group had, a hypothesis they had, and then 3 predictions that stem from that hypothesis that the students in this assessment test through graphing. So we have a visual representation of this as well, in addition to words. So this is just from our molecular biology, what a bacterial protein generation, kind of protein production kind of scenario. And so we have a question, we have the hypothesis, we have kind of this relationship between variables and processes, a visual depiction of the hypothesis. And then we have 3 predictions, and that like 3 graduate students would be, or students would be aiming to answer or to address. So, and then we give them a data set. So this is within Symbio's platform. And maybe some of you have used Symbio simulations. This isn't a simulation as much, but it's a static data set. But what we put in here is a large enough data set that students would have to graph. They couldn't test the predictions just by scrolling through the data. There are too many data points there and too many variables. And so there's a mix of categorical and quantitative data. There's, in this case, 15 sets of data. We have 4 different bacterial species in this scenario. And we really wanted to get at their ability to pick out relevant variables as part of this. And so there's a list, there's some of these variables are more or less, or maybe even irrelevant to testing any of the predictions, right? So they had to choose, make some decisions. And then we, what I'm simplifying years of research and design with lots of iterations and interviews and things like that. So I just, I was looking at the chat. Sorry, I'll wait on that. I always want to attend to make sure there isn't clarifying questions, but we simplified a lot of things, right? And someone mentioned in the Padlet about, seemingly randomly picking a graph type in Excel, right? There's only 3 graph types that they could select from, which is a limitation, but we had to decrease the parameter space somewhat to be able to interpret our data. So there's a scatter plot, line graph, and bar graph. They select the data. It's just a Cartesian coordinates here. They can remind themselves of what the hypothesis and prediction was. They could add, mean lines or error bars. They can go back and explore the data. And then if they want, or if it's needed for a prediction, add a 3rd variable with color, right? So, but it's pretty constrained. And then, sorry, I clicked in the wrong place. So then what we have done is in the 23-24 academic year, we deployed our assessment for large scale use. And so we had over 7,000 students from different institution types from across the United States in over 100 different classrooms take this assessment. So we wanted to understand, we started with small n studies in my own group, and then now we have this large n study. And we had questions in this assessment that were embedded in there to gain specific insight into 6 graphing related areas. And I'll come back to what this means later. But picking relevant variables, being able to describe patterns in data, making claims from data, selecting the right graph type, the representing variability, and then also, related to kind of choosing and evaluating different graphs as well. And so we have different questions. They graph the data, but then we have additional questions in there. So we have some drop-down questions. I complete this sentence. They would look at their graph and they would just describe the pattern there that they see. And then we ask them to like make a claim. Do the data support or refute the prediction, and explain? This is around, okay, you could have made one of 3 types of graphs and you made whatever it was. Why did you choose that over the other ones? So it's free response. We have a question in there to help us understand how they understood variability and variation. We gave them, this is the choosing of pre-made graphs. Which ones do they think represent the data best? So they make the graph, but then they are also given graphs. I'll come back to that. And then we analyze the graphs that they made, right? And there's some overlap with what we can analyze in the graphs they make with these other questions. So we have multiple lines of evidence for some of the areas we were interested in. And so, sorry, I'm looking at my watch. So I want to make sure we have time. I could talk about this for days, as Melanie knows, but so we employed a variety of different ways to analyze the data. So we scored the graph. We have 3 predictions. So we used a technique called Bayesian knowledge tracing. So each student would have 3 chances to make a graph. And so we would just continually update their score with each prediction that they made to get a final score for them across making graphs for all 3 predictions. We've also done some item response theory. So this is part of like evaluating our assessment. We meaning our collaborators in this case at SymBio, some auto scoring strategies, because we have over 7,000 student responses, right? We had initially hand scored all of these free response, and created meaning from those, but then we collaborated with our friends at UPenn who have natural language processing expertise to be able to still ask free response questions at that scale. So we've done a lot of different ways that we've been able to analyze our data. So I just wanted to give you just a little taste. Can always happy to share offline or otherwise, but just some general findings. So the students' strongest areas were at axis conventions. I know one person mentioned that, and that what I mean by axis conventions is putting the dependent variable on the y-axis and the independent variable on the x. Students overall did pretty well with that. And then they do a pretty good job of like reading and describing and interpreting their own graph. And I say that bold and italics, it doesn't mean that they pick the right variables for each prediction, but the graph they made, they usually could read and interpret. It might not be the one that was relevant or best to test each prediction, but where they could use some more support, which resonates with what you all put in the Padlet, right, is selecting the most appropriate graph, and also the form of the data, the raw data versus aggregate data to use, and then applying statistical knowledge when creating graphs and making claims from their graphs. And then understanding, representing, and interpreting variability. So those were kind of some things that fell out, and I'll that big picture, and then I'm going to show you just little pieces of data that relate to these. So we scored the graphs, right? So we had to create a way to do that. So what could we measure from the graphs that students actually made? And so we could evaluate, did they pick the right variables for a given prediction? So in this case, this graph would get a high score there. They picked the right, basically they looked at the prediction, it was almost telling them which variables to plot. And so we could evaluate that. In this case, that would be a high score. Picking this, I'll come back to this, picking variables that could be related to each other in the context of this prediction. In this case, they did that, but showing, that data aggregation, really, putting the raw data is not ideal here. And kind of sometimes relates to data variability. And in this case, having the raw data and having the multi-bar kind of graph is not ideal. The axis conventions are actually flipped, and then the scaling is, they're not centering the data. There's all this white space doing nothing up here. So they would have got it in the lower, so just lower scores, just to give you an idea of what we were looking for. And then what's shown here is the output from this Bayesian knowledge tracing, right? So the accumulated performance on these things that I just told you about in the previous slide, with us on a scale from 0 to 1. And so, like I said, they would make the first graph and they would get a score. And then that score for each of these things would be updated each time they did a graph to be able to get this final score. This is the distribution or the data density in these violin plots for one scenario. We call it the lobster scenario. So there's 677 students represented here. So what this is showing is that students did pretty well in this case, although there's a range, but most of the data density is the better score for the data aggregation and picking variables that could be related to each other. Variable relevance, they did okay, but the predictions, kind of point them to that a little better, but there is a range here. But then you can see where there was a bigger spread in the data for some of the other things, including picking the right, doing the data variability or picking the right graph type, for example. And then what's inserted in here is also like the box and whisker plot. So that you can kind of see that. So we looked at it that way, but then we've also collapsed those into a total graph score. And so what's shown here is that total graph score from 0 to 1. So it's based on that Bayesian knowledge tracing score accumulated across making 3 graphs per student. And now what I'm showing you is what that looked like when you collapse all of those sub-factors into one graph score across our different scenarios. And this is where we had it at the time I made this graph before. I need to update some of these numbers. But again, these violin plots. And so I can come back to a slide later on this, but just in case you're curious and you want to ask later, we have made some pairwise comparisons, and we do see some differences in how students do that based on the institution type where they are, the numbers of semesters that they've had in college, and then some other student level demographics. So we kind of tried to pull things apart, and I'm happy to chat about that, but I want to make sure that we have time for you all to kind of talk too. I am curious. I have this question here. So what's shown are just a subset of the kind of graphs that could be made with this graph constructor here. And I have like letters for each of them. So this, F would be this graph, C would be this graph, A would be this graph. And so I'm curious in the chat if you could put what you think. Which graph type do you think was the most commonly one made? And you could enter, A if you think this is the most common, B if you think this, C, and so forth. So you can put that in the chat. I'm curious what you think of these choices based on your experience. Which ones do you think they would make? Ooh, lots of A's. A or B. F, okay. So there's a lot of different ones. So we've got some E's. That's this one. Some B's, an A or F. Okay, yeah. Thank you for putting your kind of vote in there. So let me make sure I've got clicked on here. All right, so here's what we saw. And so this on the y-axis is the percent of all the graphs that were made in our data set. And then here's, you notice that I also had this color coded, right? So the most commonly made graph was B. That's this orange one here. So students most commonly, when they had, 2 treatments and then a quantitative variable, they most commonly made this one, the multi-bars graph. So another question we have in our assessment is that I mentioned, students were given 6 pre-made graphs, and we wanted to kind of look at their graph knowledge and decision making from 2 different perspectives, what they would choose to make, and then if they were given graphs, what would they choose to select. What was interesting is from the pre-made graphs, they were far more likely to pick this one. So students did not always make the graph that they chose. When they were given a graph, they were more likely to pick an average with error bars, but left to themselves, and making a graph, they plotted the raw data. So that was kind of an interesting observation. And then this one, I always like to talk about this one, and Lauren is here, this is her baby. I would just like to give credit and enthusiasm where that's due. But we also have questions in there to get an understanding of how students think about variability, and error bars. And so we have a couple questions there. We asked them to what degree or how easy is it to interpret variability within a category, and with it's not shown, easy, or hard. And then this free response question is, what information do error bars provide? And they can also say they don't know. So Lauren and some undergraduate students did a lot of work on this project. And so of the, looking at variability, how easy is it or hard, or it's not shown, what's interesting to me is that they think that it's easy to interpret variability, and it's actually not shown on this graph. I mean, it's split, it's not evenly. I don't think it's as easy in this kind of graph, but students thought so. Understanding variability in this one, which is kind of, where we would probably think that it's present and should be easy to interpret. Yeah, so it was interesting to see the different ideas that they had around how easy it was to interpret variability there in the different graph types. So suggesting a lot of differences in how students are thinking about variability and as it's represented, and variation in these graphs. And then this other one was looking at error bars, and they could say, were they unsure, they didn't know, or they were pretty, they were confident or that about error bars. And so what Lauren, and there's a lot of stuff going on here, but they analyzed that free response, like what do error bars, represent basically. And they divided that into these, if you look at this center pie chart here, into 3 different groupings. And so students talking about trend and analysis, thinking about it in broad terms, thinking about what, the form that the error might be in, and what error bars, what their purpose is. So it was just kind of interesting that students are thinking about, and these don't add up to 100% because a given student could say more than one thing. And Lauren and I each have our things that we think are really interesting. What I think is interesting is that there's a diversity of ideas. And then also what I found fascinating is this one, accuracy and precision. And that's my own past experience. And that reminds me of chemistry and thinking of accuracy and precision. And so Lauren was a trooper when I asked her to go back and look through the data to see, did anyone talk about natural biological variation? Like, is that what is being, is that represented in there? And it was not. They really were kind of talking about there was some kind of mistake in the data, an error in the data, or some kind of error in making the measurements, or they just weren't, things weren't precise enough. But, there's a lot of, some students talked about, what their purpose, what you could do with them, allowing some analyses and just more in broad terms. So there's a wide variety of things. So the next thing I wanted to do, and this is leading, it's a lot of information, even though it's just a taste, is to set the stage for you all talking to each other. And I'm already run out of time, I think. But one of the things that we use that I think of as a roadmap for learning objectives really is we created a model that we call the graph construction competency model for biology. And it allowed us to kind of outline what we wanted to measure. And so we had 4 different categories that are listed here around selecting data, exploring data, making the graph, and then doing some reflective practices. And we identified some skills related to that. And we just got word that the paper was finally accepted, but we did a literature review. We had our own experiences, our own research, and we had some focus groups with some biology and statistics education researchers and educators. And just to kind of, I wanted to orient you to this before we kind of break out and talk a little bit. So data selection. You can put the thing in the chat if you want, Melanie, but you'll see a slide deck that has these 4 slides in it. And so just to let you know, orient you to it. So data selection refers to understanding the type of data. Is it quantitative or qualitative? Thinking about variables, if they're relevant or not. Are you picking variables that could be causally linked together? Data filtering and prioritizing, like plotting the data points, excluding missing data and things like that. Exploring the data, so understanding, individual data versus, data as a distribution, like data points versus as part of a distribution. Thinking about either plotting individual points or summarizing them. Picking an appropriate statistic, so a mean or a median, representing variability. If if they're plotting like an average, for example, having some kind of standard error or standard deviation or some other form representing variability. Then things related to assembling the graph, so picking graph type, plotting the points, following, the scaling and axis conventions, as someone put in the Padlet, labeling it, axis labels and title, and that aesthetics component. And then finally, these reflective things. So being able to read off points, being able to describe the basic pattern, that's upstream of interpreting it, so making a claim, and then related to that question, whether they're given a set of pre-made graphs, like when more than one kind of graph type could be appropriate, reflecting on the affordances and limitations. Like, would you make a bar graph? Would you make a box and whisker plot? Would you make a violin plot? Like, all those could be appropriate, but for your purpose, one or the other may be more appropriate. And so what I thought, I wanted to kind of walk through what that meant. You have that slide deck, and that's yours to keep. But I wanted you to, and that this is just the link that I mentioned, and what I thought could be interesting for you all to have some time, and Melanie was going to create breakout rooms, and maybe it's only going to be for like 10 minutes or something like that. Sorry for that. I get excited and then I overtalk. But is to kind of think about your own teaching and any activity or assignment that you might do in your own classes. So which parts of this framework align with what you already do? Are you collecting, what evidence do you have that to help you understand student learning? How might this framework be useful to you to construct learning objectives, to guide assessment instruction. And so you can talk in your breakout rooms and kind of share what you do for your teaching and what was interesting. And we can come back and I'm going to share some of the things that I do in my own teaching. But and then if there's time, we could maybe hear from some of the breakout rooms. But I apologize. I had it all timed out and I got excited and overtalked.
You did great. I will go ahead and create those rooms. Oh, you know what I did, Steph? I did 3 rooms instead of 3 per room.
That's okay.
So we'll have big
It's all good.
we'll have big discussions. I apologize.
It's all good. And then maybe I think we can usually like send a message with the questions
Yes,
broadcast to
there's a
all.
broadcast.
Yeah.
Yes.
So I'll put it in the chat for you to then maybe broadcast because I don't know if I can do that because I'm not a host. So
Sure.
I'll send the
Or
yeah,
okay.
go ahead.
Yeah, that's fine, Steph. I was gonna say I can also make you co-host, but that's fine.
Yeah.
Okay, got it.
I guess I forgot to put the pair, but yeah.
Okay. Yeah, I feel like every time like I see it, I keep learning something new. So,
Were you able to broadcast it? Nice.
yes. And I'm gonna do, yeah. Yes. Okay, it's not too bad. There's about 4 or 5.
Yeah.
That's not, yeah, not
And even if they just go in there and just chat about whatever, that's fine too.
okay. Okay. Thanks for
Yeah.
your patience stuff.
Well, and I had it all planned out
No worries. It's
and
all
then the
good.
time.
It's it's a lot, like it's a lot. You did a lot. It's like, and you kind of can't rush some of that, you know.
Mhm.
You have to kind of step through it.
And I took out a lot of stuff, but oh well.
No, it's all good. It's good. Um, okay. Maybe well, no, then I won't be able to close them. Okay.
What's that?
Oh no, I was gonna say I could jump in a
Oh, if
room.
you make me
Oh,
a co-host, I know, and I think, yeah, I was gonna click that. Yeah, I can share with you what I do. Let me, whoops, let me share my screen of things that I actually do in my own teaching. So let me get this. Um, oh, let me go back. All right. Can you see my screen again? Okay. Yeah. So this is literally something I do early in the semester as I draw from this a figure from this paper, which I highly recommend if you don't know about it. It is a paper, it's called Beyond Bar and Line Graphs, Time for a New Data. I can't remember. Beyond Bar Graphs is my shorthand for it. And so I show this as a multiple choice question for the students, and I ask them, looking at this bar graph, so let me put my pointer on again. Which of these or multiples of these could be the raw data that make up the data that are plotted here in this graph, right? And so I ask, students, they can think about it, and they talk in their teams, and then I have them vote, and it's all over the place. And no, hardly any of the time do students actually realize that it's all of them. And so this course context is you could use it in a lecture at the lab, depending. I use it in my lab. And so I want to understand students' ideas around descriptive statistics, variability, variation, and graph types, right? So those are my goals. And I have a guided discussion with this. And it's a part of a bigger thing that we do around graphing at the beginning of the semester. So I want them to think about the affordances and limitations of different graph types and data analysis choices. And so related to the GCCM bio and the learning objectives I have, right? It gets at graph type, data form, data summarization, statistics selection, data variability, and the graph communication. And so assessment ideas, I use this as a formative activity, but you could use it in more formal context and for grading. I just use it as a conversation starter and discussion. But you could make multiple choice questions around this. You could have any number of ways that you could use it, something that I use. And then the other thing that I do is it's in my physiology lab component, and I have a rubric that we've built from some of our research that we did, and I use it in my class, and I want them to understand the rubric and learn my expectations, but also kind of break down all the different things that go into graphing, and so that helps with that. And it also helps to reveal the areas of competence and challenges that they may have. And then again, I have guided discussion. I give them graphs to evaluate, and then we kind of have a norming discussion about it. And so it really hits at most of the GCCM bio areas. And so this is just an example. It's from a grip force lab. They squeeze on a transducer and they design simple experiments. And so I just show them some example graphs and the hypothesis and or prediction that students in previous years had made. And I have them use the graph rubric so that they can, evaluate. Like here, someone in the Padlet, right, says something about extra lines, like, like all of these lines, but then also the scale isn't quite right. And this one, the scale is, it's not starting at 0. So it's exaggerating potential differences. And this graph, you wouldn't do this across categories, right? So it allows us to discuss a lot of different things around graphing, and we've published this rubric, but also happy to share with Melanie or whatever the dissemination outlet is, how I use it in my class too. And so I actually, evaluate student graphs over the course of the semester. So those are just a couple of things that I do, some examples, and I know we're basically out of time, and I apologize. I like I said, I could talk about this for for days, and that's a problem. But that's some examples of graphing that I do. So we have a rubric and we have that guided discussion. And I'd like to have them generate a data set and submit graphs as a way for me to understand what's their go-to, right? And then build from there. And I do that early in the semester. And very formative kind of exercises to help them and collaborate with them in their learning. But they get lots of practice throughout the semester because they design experiments and report on their findings. But I immediately really time for questions. I wanted you all to talk and just need to acknowledge all the many people involved in this over the years. But I will actually, if I can find my cursor again, there we go. Stop sharing my screen. And oh, thank you, Lauren. Awesome. I know it's at 5:01.
Yeah. I know we're at time. I just wanted to give a big hand to Steph Gardner. Thank you so much for being with us today and for doing such a wonderful presentation. And I will stop the recording. And if you have a few minutes to take a few questions, I